This module includes Introduction, Movement of Earth, Endogenic Forces, Exogenic Forces, Work of a River, Work of Sea Waves, Work of Glaciers, Work of Wind, and Recapitulation. Have you carefully observed the land around you? Is it the same everywhere? No. We can see a lot of diversity around ourselves. At different places we find mountain ranges, deep gorges, plateaus, plains, etc. How did this happen? These variations are due to the natural forces acting inside the earth. Lithospheric plates. The topmost layer of the crust of the earth, lithosphere, is broken into a number of plates known as the lithospheric plates. Endogenic forces are further subdivided into sudden forces and dystrophic forces. Sudden forces. It includes volcanoes, earthquakes, landslides. Dystrophic forces. It includes mountain building. Endogenic forces. Chief characteristics of endogenic forces are: these originate deep inside the earth. These factors are caused due to the convection currents in the mantle and the movement of the lithospheric plates. Sometimes the endogenic forces produce sudden movements and at times low movements. Volcano. A volcano is an opening on the surface of the earth or crust that allows hot, molten rock, ash, and gases to escape from the interior of the earth. The following animation will give the detailed explanation of the concept.
Volcanoes are formed when hot material from below the surface of Earth rises and leaks onto the crust. This hot material consists of lava, smoke, lava bombs, ash clouds, etc. This hot material called magma comes either from a melt of subducted crustal material, or it may come from deeper interior of a planet, and it is very hot. Magma rises from the magma chamber, which erupts into the surface. Magma that reaches ground level is then known as lava. As the amount of magma increases, it ascends to the surface. Repetitive eruptions of lava and solid matter results in the formation of walls or the cones of the volcano.
Volcanic activity tends to form volcanic mountains over a period of time. For example, Mount Kilimanjaro in Tanzania, Mount Fuji in Japan. Have a look at these series of pictures to know the various forms of volcanic destruction. Test yourself. What are the forces which act in the interior of the earth called? The options are A. Endogenic forces, B. Exogenic forces, C. Frictional forces, or D. Air resistance forces. Earthquakes. The movement of lithospheric plates causing vibrations on the surface of the earth is referred to as an earthquake. Have a look at the figure given below. Let us watch the animation for a better understanding of the concept.
An earthquake is a natural phenomenon which can cause destruction on the earth. Earthquakes manifest themselves by shaking and sometimes displacing the ground. They are the earth's natural means of releasing stress and cannot be predicted. When the lithospheric plates move towards each other, they may slide past each other, creating faults and creating seismic waves. An earthquake's point of initial rupture is called its focus or hypocenter. The term epicenter refers to the point at ground level directly above this. Shaking and ground rupture are the main effects created by earthquakes, resulting in more or less severe damage to buildings or other rigid structures.
Seismograph. A seismograph is an instrument that detects, magnifies, and records vibrations of the earth, especially the earthquakes. Richter scale is a mathematical formula which determines the strength of waves recorded on a seismograph. The resulting measurement defines the exact size of the quake. Let us have a case study on the earthquake that happened on the 26th of January 2001 at Bhuj in the state of Gujarat. Here are some particulars of that catastrophe. Date of occurrence, 26th January 2001. Time, 8:46 a.m. Magnitude, 6.9 on the Richter scale. Epicenter, 23.6 degree north latitude and 69.8 degree east longitude. It occurred 20 km northeast of Bhuj and 110 km north-northeast of Jamnagar. One of the worst to have occurred in the country during the last 180 years, for which the seismological records are available. Approximately 20,000 people were killed. Over 6 lakh people were rendered homeless. Damage estimates in US dollars was about $1.8 billion. Have a look at the effects of the earthquake with the help of this series of pictures. Earthquake preparedness. Safe spot. Under a kitchen counter, table, or desk against an inside corner or wall. Stay away from fireplaces, areas around chimneys, windows which shatter, mirrors and picture frames. Be prepared. Spread awareness amongst friends and family members and face any disaster confidently.
Landslide can be defined as the movement of a mass of rock or debris down a slope under the influence of gravity. Landslides are caused by the following factors. Ground causes, which includes weak, sensitive, or withered materials, adverse ground structure, joints, fissures, etc. Morphological causes are ground upliftment, volcanic, tectonic, etc. Erosion, wind, water. Physical causes constitute prolonged precipitation, earthquake, volcanic eruption, thawing.
The two regions most vulnerable to landslides are the Himalayas and the Western Ghats. However, compared to the Western Ghats region, The landslides in the Himalayas region are huge and massive. The landslide-prone area of India are shown in the given map.
Let us now move on to the exogenic forces. The forces which work on the surface of the earth are called exogenic forces. The surface of the earth is continuously changing by two processes. One, weathering, and two, erosion. We shall know about these processes separately in the following slides. Weathering. Breakdown and alteration of rocks and minerals at or near the surface of the earth is known as weathering. Converted into products that are more in equilibrium with the conditions found in this environment. Erosion. Influences behind erosion are either gravity or natural agents such as water, wind, and even ice in glaciers. We'll now study about the erosional and depositional works of river, sea waves, glaciers, and wind in detail. The work of a river. Running water in the rivers erode the landscape. Middle course. When the river descends to the lower levels, it runs more slowly over the gently sloping land in its middle course. Its current no longer has the force to carry stones or gravel. These materials are dropped on the riverbed, where it forms bars of sand or gravel or builds islands. Lower course. As the river flows downstream, it reaches the still gentler slope in its lower course, drops more of its loads than it did upstream, and begins to build up its bed instead of tearing it down. The valley is then eroded into a wide plain. The river swings in great S-shaped curves, forming loops called meanders. Let us have a look at the animation on waterfall, which is usually formed in the upper course of a river.
Waterfalls are usually found in the upper course of a river, in the hills or mountains. Waterfalls are formed when a hard layer of rocks cover a soft layer of rocks. Water flows over hard rock, and when it reaches the soft rock, the water starts to erode or wither away the soft rock. Over thousands of years, the soft rock is eroded and the river begins to cut down vertically into the rock. This makes the cliff over which the water can topple. Over the period of time, the cliff becomes steeper and deeper, and the waterfall is formed. At the bottom of the waterfall, a plunge pool is created. Some of the water splashes onto the cliff and makes a large hollow plunge pool by a process called undercutting.
Around the world are Angel Falls, Niagara Falls, and Victoria Falls. Floodplain. Layers of fine soil and other sediments are deposited along the riverbanks because of flooding. This leads to the formation of floodplains. Floodplains are very fertile. For example, the Indo-Gangetic floodplain. Meander. It is formed when the moving water in a river erodes the outer banks and widens its valley. As the river descends from the mountains, and enters the plains, it forms large bends known as meanders. The following animation will give a detailed explanation of the concept.
As the river reaches the plains, it starts meandering. In the lower course, the meanders become even larger. The erosion causes the meander neck to narrow. Erosion on the outside of bends and deposition on the slip of slopes continue to take place. This results in the shifting of the river course. The deposition of the fine alluvial soil results in the formation of the fertile floodplains. The deposition process keeps increasing the meander loop in size. The neck of the meander further closes until eventually it breaks through. The river now follows a straight path. After the meander has been cut through, the river seals off the bend by deposition and an oxbow lake is formed.
Oxbow Lake and levees. An oxbow lake is a U-shaped body of water formed when a wide meander from the main stream of a river is cut off to create a lake. The raised banks of the river are called levees. Delta. As a river approaches the sea, its speed becomes slow and the river breaks into many distributaries. It leads to the deposition of sediments at its mouth and a delta is formed. We'll look at the different works of sea waves through this series of pictures. Ocean waves are caused by the wind as it blows across the surface of the water. Tides, waves, and ocean currents make the ocean restless. Waves are a powerful source of energy. Waves erode the coasts and deposit the eroded debris at some other place. A number of topographical features are made by these waves. Try to understand the work of sea waves through this animation.
Coastal landforms are formed due to erosion and deposition. Sea waves strike continuously on the rocks. The waves erode and weaken the rock face to form a hollow or a sea cave. Continued erosion enlarges the hollow and makes natural arches. Slowly, its roof collapses. When the arch collapses, the seaward pillar is left standing and becomes a stack. Continual wave erosion eventually reduces the stack into a stump.
Discuss the different features formed by the work of sea waves. Sea caves. Continuous striking of the sea waves at the rocks develops cracks. After some time, these cracks become larger and wider. These hollow caves are called sea caves. Sea arches and stack. When the cavities become larger and leave only the roof of the cave, sea arches are formed. When the roofs of the sea arches are further eroded and only the wall is left, sea stack is formed. Cliff and beaches. Sea cliff, steep rocky coast rising vertically above seawater. Beaches, the deposition of sediments along the shores. Now we will have a look at the work of glaciers. The accumulation of snow and ice on mountains and polar regions over a long period of time form glaciers. Glaciers are slow-moving rivers of ice. They perform erosional activities and carve out deep hollows. Look at some of the facts about glaciers. Glaciers and pack ice contain approximately 75% of fresh water of the world. 10% of the Earth's land area is covered by glaciers. Nearly 1 lakh glaciers are in Alaska, and most of them do not have names. If all the glaciers are melted, the sea level would rise by about 230 feet. Some of the famous examples of glaciers are Baltoro Glacier in the Karakoram Mountains, Pakistan, is one of the longest alpine glaciers on the earth. Its length is around 62 kilometers or 39 miles. Altet Glacier in Switzerland is the largest glacier in the European Alps. Lakes. Glaciers carve out deep hollows. When ice melts, these lakes get filled up with water and become lakes in the mountains. Examples of glacial lakes. The Great Lakes or Lake Superior, Lake Michigan, Lake Huron, Lake Erie, and Lake Ontario are the largest glacial lakes in the world. Glacial moraines. The materials carried by glaciers such as rocks, sand, and silt form the glacial moraines. Let us have a look at the different works of wind through this series of pictures. Different kinds of landforms are shaped in areas where the wind action is strong. For example, in the semi-arid and arid zones. We shall now discuss some of the features formed as a result of the work of wind. Sand dunes. These are low hill-like structures formed due to the deposition of sand, which falls from the upper parts of the rocks as the winds cause obstruction. For a detailed explanation on the formation of sand dunes, watch the animation carefully.
Wind is an active agent of erosion and deposition in the desert region. Sand dunes or sand hills are formed from wind-blown sand. When the wind blows, it transports the sand from one place to another. When the wind stops blowing or there is an obstacle, the sand falls and gets deposited at a new place, forming a new sand dune. In the cross-section, you can see how the sand dune shifts from one location to the other. Most kinds of dunes are longer on the windward side because the sand is pushed up the dune and a shorter slip phase in the leeward side of the wind.
Some famous examples of sand dunes are the dunes in the Thar Desert in Rajasthan, India, Totori Sand Dunes, Totori Prefecture, Japan, Rige-Jen in the Central Desert of Iran, Rige-Lut in the southeast of Iran, the Ilocos North Sand Dunes in the Philippines, particularly Poway Sand Dunes. Loess. Loess is the very fine-grained sand deposited by wind in large areas. It is found extensively in parts of northern China, Mongolia, and the central US. Mushroom rocks. Winds erode the lower parts of a rock more than the upper parts because the more suspended particles are present near the surface. The blowing wind cuts the rocks, and these take the shape of a mushroom. Let us try to understand the formation of mushroom rocks through this animation.
आप मरुस्थलों में छत्रक की आकृति की शिलाओं को देख सकते हैं। इन्हें सामान्य रूप से छत्रक शिला कहा जाता है। इनके बनने के बारे में जानना बहुत ही रुचिकर है। यह अपर्दन और अपक्षय क्रियाओं का परिणाम है। हवा के द्वारा धरती के कुछ फीट की ऊंचाई के क्षेत्र में बालू के कणों के उड़ने से अपर्दन अधिक होता है। इस कारण शिला के आधारीय भाग में शीर्ष भाग की अपेक्षा अपर्दन तेजी से होता है। आप देख सकते हैं कि शीर्ष शिला का अधिक अपर्दन नहीं हुआ है। ये शिला के रासायनिक संगठन के कारण है। वायु की दिशा के आधार पर शिला की सभी दिशाओं में अपर्दन की क्रिया चलती रहती है। छत्रक शिलाएं हजारों वर्षों में उस समय बनती हैं जब एक विलक शिला पर अपर्दन की क्रिया आधार और शीर्ष पर अलग अलग दर से चलती है।
Test yourself. What are the low hill-like structures formed due to the deposition of sand in deserts known as? The options are A. Sand dunes, B. Mushroom rocks, C. Glacial moraines, or D. Sea caves.
Let's summarize the topic. The Earth's crust is broken up into many large and small plates. These plates are known as lithospheric plates or tectonic plates. The forces which work on the surface of the Earth are called exogenic forces.